Have you ever wondered how your favorite apps manage to run smoothly despite millions of users accessing them simultaneously? It's like a well-choreographed dance, isn't it? That's because behind the scenes, they're powered by an intricate network of microservices, orchestrated by Kubernetes. Now, let's rewind a bit. Traditionally, applications were built as one big block of code known as a monolithic architecture. Imagine a giant, intricate Lego castle. It looks grand, right? But what if you want to change a piece in the middle without toppling the whole thing over? That's a challenge. In a monolithic architecture, changing or updating one part of the application often requires tinkering with the whole thing. It's like trying to change a tire on a moving car. Not exactly ideal. This approach also means that if one part of the application crashes, the whole thing goes down. It's an all-or-nothing deal. But then along came microservices. Picture this, instead of one big Lego castle, you have multiple smaller Lego houses. Each house operates independently, but they all form part of the same Lego village. If you need to change a piece in one house, you can do so without disturbing the others. This is the essence of microservices. They break down applications into smaller, independent services that can be developed, deployed, and scaled individually. And who's the mastermind managing these microservices? That's where Kubernetes comes in. Kubernetes is like the mayor of our Lego village. It ensures that all the houses work together harmoniously, managing their interactions and ensuring that resources are properly allocated. Now, imagine if these apps were like a busy city, and microservices were the traffic cops directing the flow of data. It's quite a sight to behold, isn't it? Consider the city analogy again. What if the traffic cops could multiply themselves based on the traffic volume? Imagine an intricate, bustling metropolis where traffic ebbs and flows throughout the day. Each intersection, each roundabout, each traffic light is like a microservice. They're individual components, each performing a unique function, but working together to keep traffic moving smoothly. Now, imagine a traffic control center overseeing this entire operation, ready to deploy more traffic cops to congested areas or redirect traffic when a road is closed. This control center is akin to Kubernetes, orchestrating all the microservices, ensuring they interact seamlessly and efficiently to keep the city, or in our case, the application, running smoothly. Let's delve into a real-life example. Think about the popular streaming service, Netflix. On a Friday night, when everyone's settling in for a movie marathon, there's a surge in demand. The play button is like a busy intersection with a constant stream of requests from users wanting to watch their favorite shows. Netflix, using a microservices architecture, has individual services to handle these requests. One microservice could be responsible for user authentication, another for content delivery, and another for maintaining your continue watching list. Now, as the demand increases, these microservices may start to struggle. This is when Kubernetes steps in, like our traffic control center. It can identify the services under heavy load and automatically scale them up, deploying more traffic cops to handle the increased traffic. When the movie marathon ends and the demand decreases, Kubernetes scales down the services, ensuring resources are used efficiently. Just like a city can't function without its traffic system, an app can't function without microservices and Kubernetes. It's all about having the right components in the right places at the right times, working together to keep everything running smoothly. What if the city could continue to function even if one traffic light went out? That's the beauty of microservices in Kubernetes. Imagine a bustling city, filled with skyscrapers and roads teeming with vehicles. Now, this city represents a traditional monolithic application, a single indivisible unit where each component, like traffic lights, is interconnected. If one traffic light malfunctions, it can cause a ripple effect, disrupting the whole city's flow. But what if we could design our city, our application differently? What if each traffic light was independent, unaffected by the other's status? That's where microservices come into play. Each microservice is like an independent traffic light, functioning on its own. If one goes out, the others continue to work, preventing a citywide traffic jam. This is the principle of resilience and independence that Kubernetes and microservices offer. Now, let's talk scalability. In our city scenario, what if there's a sudden influx of cars, maybe due to a big event? With a traditional traffic light system, it would be challenging to manage this surge. But with microservices, we can simply replicate or scale up the traffic lights, managing the busiest intersections. That's the beauty of scalability in Kubernetes. It allows us to handle increased traffic effortlessly, keeping the city flowing smoothly. Then comes reliability. In a monolithic application, a single bug can bring down the entire system. But in our microservices city, a bug in one traffic light doesn't affect the others. They remain green and operational, ensuring continuous service. This is the reliability that Kubernetes offers with microservices. Lastly, let's touch on the independence of services. Each traffic light, each microservice can be developed, deployed, and scaled independently. This means that teams can work on different parts of the application without disrupting others. Imagine city maintenance teams working on different traffic lights independently without causing a citywide shutdown. That's the level of independence microservices bring to the table. In essence, Kubernetes and microservices help your favorite apps stay online and perform optimally, no matter how many of us are trying to use them at the same time. But it's not all smooth sailing. Implementing microservices in Kubernetes comes with its own challenges. Now let's get real here. Just like any other technology, using microservices in Kubernetes isn't a walk in the park. It has its own set of hurdles, the first one being complexity. Yes, you heard that right. Microservices can be complex. This architecture breaks down applications into multiple independent services, each with its own database and business logic. You can imagine the complexity involved in managing these services, especially when they start to multiply. And let's not forget about the network. With all these services communicating over the network, things can get messy pretty quickly. You'll need to deal with network latency, fault tolerance, message formats, and network reliability. Sounds like a lot, right? Now, moving on to the second challenge, the need for a cultural shift in the organization. Implementing microservices in Kubernetes isn't just about changing your technology stack. It's about changing the way your organization works. It involves shifting from a monolithic mindset to a microservices mindset. And that's no small feat. Let's take a real-life example to make this more vivid. Consider a company, let's call it Techie Titans. They decided to jump on the microservices bandwagon and chose Kubernetes as their platform. However, they soon realized that their team was not ready for the cultural shift required. They were used to working on large, monolithic applications and struggled to adapt to the new, decentralized way of working. The transition was rocky, to say the least. But here's the thing, folks. Despite these challenges, Techie Titans didn't give up. They understood that the road to microservices in Kubernetes is not a straight highway, but a curvy mountain road with a few bumps along the way. They took the time to train their team, worked on their communication, and gradually, they started to see the benefits of this architecture. While the road to microservices in Kubernetes can be rocky, the benefits often outweigh the challenges. So, are microservices in Kubernetes the future of app development? This question has been at the heart of our discussion today, and it's certainly a fascinating one to ponder. In our journey through this video, we've explored the intriguing world of microservices and Kubernetes. We began by introducing these concepts, breaking them down into bite-sized pieces for easier digestion. We learned that microservices is a design approach that breaks an application into small, loosely coupled, and independently deployable services. We also discovered that Kubernetes is a powerful platform that manages these services, ensuring they work together in harmony. We then went on a little adventure, using real-life examples to bring the concept of microservices in Kubernetes to life. Remember the bustling city analogy? Just as traffic lights and road signs manage the flow of vehicles in a city, Kubernetes orchestrates the flow of microservices in an application. We also delved into the benefits of this architecture. It offers flexibility, scalability, and resilience, qualities that are highly sought after in today's fast-paced digital landscape. But it's not all sunshine and rainbows. We also confronted the challenges of implementing this architecture. It requires a shift in mindset, a robust infrastructure, and a team ready to embrace change. Yet, despite these challenges, the industry is increasingly adopting microservices and Kubernetes. Why? Because in a world where change is the only constant, these tools equip us to adapt and evolve. They empower us to build applications that can scale with demand, recover from failures, and innovate at speed. In conclusion, while it's hard to predict the future, one thing is clear. Microservices and Kubernetes are reshaping the way we build and use apps. They're not just tools or technologies. They're a new way of thinking about software development. And remember, next time you're stuck in traffic, think about microservices and Kubernetes. They might just provide the perfect solution to help you navigate the complex, ever-changing highways of the digital world.